Workers face daily exposure to potential hazards. Correct precautionary measures can prevent accidents and make welding as safe as any other metalworking occupation. Metalworking hazards include exposure to hot metal, sharp edges, and working around moving machinery. For welding, there are additional hazards such as electric shock, arc radiation, air contamination, flying objects, fire, and explosions. To ensure safety for workers, laws have been created which prescribe regulations and warnings. The Occupational Safety and Health Act, or OSHA, makes many national standards enforceable by law. One of the most important of these standards is the American National Standards Institute Z49.1, Safety in Welding, Cutting, and Allied Processes. This standard states that welding and cutting operations pose potential hazards from fumes and gases, electric shock, heat radiation, and even excessive noise. Employers are required to establish comprehensive hazard communication programs to inform workers about dangers in the workplace. By the same token, the employee is obligated to learn and use safety practices, obey safety rules, and take proper care of equipment. The use of Material Safety Data Sheets, or MSDSs, is mandatory. These cover the potential hazards of every substance taken into the workplace. Welding electrode suppliers furnish MSDSs which must be kept on file in the personnel or welding department. Copies must be given to all supervisors, welders, and anyone connected with the welding area, and must be read and understood by all. An MSDS is divided into several sections. No specific format is required, and the sections may vary from company to company. However, the information must comply with the rules per OSHA Form 174. Using the example of one filler metal manufacturer, Section 1 identifies the manufacturer's name and the products the MSDS is applicable for. Section 2 identifies the hazards in the filler metal itself. Section 3 identifies the physical and chemical characteristics. Section 4 identifies fire and explosion hazard data. Section 5 identifies fumes and gases hazards created by the welding arc or torch, and how to sample actual fumes. Section 6 is very important, as it identifies health hazards and the effects of overexposure if proper precautions are not taken. Section 7, equally important, identifies requirements for personal protection. The electric arc is a powerful source of visible, ultraviolet, and infrared light, all of which can be harmful unless suitable protection is used. Proper clothing should have no openings or gaps which expose the skin to ultraviolet arc burns. All personal clothing should be flame retardant, dry and free of oils. Wool clothing is better than cotton because it doesn't disintegrate or catch fire. For heavy-duty welding over 200 amps, a leather jacket or apron, leather gauntlet gloves, safety glasses, spats, head cap, and a helmet with a proper filter lens must be worn. Pants legs should be without cuffs and cover the shoes. The shoes should be safety types with high ankles. Even with light-duty welding under 200 amps, the skin must not be exposed. Other personnel in the welding area should wear the same type of protective clothing. Whatever the welding application, safety glasses should be worn at all times. Contact lenses may be worn for welding, but these do not replace safety glasses. Helmets should have the proper filter lens, protected from spatter by a clear cover plate. Lens shades use a numbering system to help select the amount of darkness required for the amount of amperage used. Refer to the American National Standard Institute's Safety in Welding, Cutting, and Allied Processes to determine the proper shade needed. If unprotected eyes are exposed to the arc even briefly, ultraviolet arc burn can result, which causes the sensation of hot sand in the eyes for up to 48 hours after exposure. Up to 6 hours may pass before any symptoms appear. Eye drops or eye washes will give temporary relief. If the pain persists for more than 24 hours, a doctor should be consulted. Precaution signs should be posted in and around the welding area and should be in agreement with the American National Standard Institute's standard for accident prevention signs. This includes warnings that anyone with a pacemaker should take special precautions or avoid arc welding areas. Heat from the arc is infrared radiation, which is harmless if the welder is properly protected. But ultraviolet radiation is invisible and much more potent. Screens should be used around the welding area to shield nearby workers from the radiation and should be free from tears. If welding is done in an enclosed booth, it should be painted with a flat finish that will not reflect ultraviolet light. Metal degreasing or cleaning solvent operation should be kept at least 200 feet away from the welding area, since the ultraviolet radiation can decompose some cleaning chemicals into phosgene gas. Phosgene gas is a harmful substance with the odor of new-mown hay. If detected, the area should be evacuated and ventilated until the gas is cleared. Because of this hazard, make sure solvents on metal are thoroughly removed before welding begins. Ultraviolet light can also produce ozone, an active and harmful form of oxygen that can cause coughing, wheezing, chest pains, or a burning sensation. Proper ventilation will reduce the ozone concentration around the arc area. It is not a long-range hazard since it changes back into oxygen a short distance from the arc. Electric shock is associated with all electrical equipment or tools. Tools are ordinarily operated on ordinary 115-volt household voltage, but this is higher than the output of a conventional arc welding machine. National standards are set by NEMA, the National Electrical Manufacturers Association, or by the Canadian Standards Association. Use only welding machines that have one of these names on the nameplate. NEMA specifications provide classes of weld machines and requirements for duty cycle and maximum no-load voltage. Machines must be installed in accordance with NEMA and local codes. Instructions are given in each manufacturer's manual. If a grounding lead or conductor is part of the power supply cable, be sure it is connected to a properly grounded switch box or building ground. Use a separate grounding lead if it is not a part of the supply cable. Note that this does not replace connecting the machine's ground lead to the work surface, which is essential for safe welding operation. When paralleling transformer machines, identify each phase of a three-phase power line. This assures that the machines will be in the proper phase with each other. To check this, connect the work leads together and then measure the voltage between the electrode holders. It should be practically zero. If more than one direct current machine is connected to the same weldment, be sure that both are set to the same polarity, both positive or both negative. If they are not, the voltage between the electrode holders will double. Also, do not attach both AC and DC machines to the same weldment. Electrode holders should have flexible cables. No splices should be within 10 feet of the electrode holder or gun, and they should be well insulated. Welding machines should be located in a well-ventilated area with nothing obstructing the ventilation ports. Electrode and work leads should not be wrapped around the machine or the welder. Work areas must be kept dry. Dampness increases the chance of electrical shocks. A regular inspection and maintenance schedule should be maintained and records kept. No matter how small the problem, no one but properly trained maintenance personnel should attempt repairs on welding machines, cables, guns, work clamps, and electrode holders. Notify your supervisor of any problems or potential hazards. All power sources should have disconnect switches for maintenance purposes. And always follow correct lockout-tagout procedures. Air contamination is the smoke and fumes rising above the welding operation. These contain two types of contamination: particulate matter and gases. Adequate ventilation will reduce smoke hazards. Potential harm from fumes and gases depends on the chemical composition of the particulate matter, the concentration at the welder's breathing zone, and the duration of exposure. Particulate matter is small, often invisible solids suspended in the air, such as tobacco smoke, household dust, and pollen. When welding, the kinds of particulate matter relate to the type of electrode or filler metal, the welding process itself, the current employed at the weld location, the atmospheric conditions when welding outdoors, and the composition of base metals and coatings. Certain metals create hazardous airborne contaminants, such as brass, bronze, zinc, and others. Coatings on the metal, such as paint, oil, grease, or plastic, can also release contaminants. Welding on old painted steel work can produce smoke containing particles of lead. Newer pipe is sometimes coated with a plastic protective material which can be harmful. Proper ventilation and parent metal cleaning and preparation will protect the welder from all such fumes. An additional source of gases is flux, which is found in the coatings on shielded metal arc electrodes and inside the electrode wires used for flux cord arc welding. The flux used for submerged arc welding can also give off gases when heated. The most common gas produced by electrodes and filler wires is carbon dioxide. Carbon monoxide can also form. These gases should be removed from the welding area. Confined areas such as small and restricted spaces, tanks, pressure vessels, tunnels, or small rooms with poor ventilation can become death traps. The hazards here are poisonous, flammable, or explosive gases, oxygen depletion, or heavy concentrations of smoke and particulate matter. Exhausts from engine-driven machines are a prime source of carbon monoxide and carbon dioxide, even in less confined areas, and should always be channeled outside. Refer to American National Standards Institute Z117.1 Safety Requirements for Confined Spaces. When welding in confined areas, lookouts should be assigned to watch the welders and other workers in the area. Voice contact should be maintained throughout the welding operation. In extremely confined areas like tanks or vats, welders should wear lifelines, harnesses, or both so they can be pulled out if they are overcome. The atmosphere in enclosed areas should be checked before welding is attempted. An explosiometer can be used to test for explosive concentrations of gases and adequate levels of oxygen. Oxygen should not be used in place of compressed air to ventilate enclosed compartments. If the oxygen content of the air is even 5% more than normal, the area could become combustible when an arc is struck. On the other hand, if heavier-than-air shielding gases such as argon and carbon dioxide are used in confined spaces, the oxygen content will drop, perhaps below breathable levels. Such areas should be monitored to assure proper oxygen levels. To ventilate these areas, air exhaust and fresh air supply systems should be used. If this is impractical, a respirator or self-contained breathing apparatus can be used. Respirators can be selected and fitted by trained personnel following OSHA standards. There are 3 types of ventilation. Natural ventilation is welding outdoors or indoors in an area that provides 10,000 cubic feet per welder, with a ceiling of 16 feet and with no partitions, balconies, or other structural barriers. When hazardous materials are welded, natural ventilation must be supplemented. General mechanical systems use roof exhausts, wall fans, or other large air movers in order to keep airborne contaminants low and prevent explosive gas mixtures from accumulating. Such systems can also be used in individual welding booths. Local exhaust systems have a fixed or movable hood placed near the work area or even in the welding gun. Movable hoods can be adjusted as desired to pull smoke and fumes away from the welder. To check if the area is properly ventilated, samples can be collected and analyzed from the breathing zone under the welder's helmet. Cutting and welding in areas that are not specified or approved for such work cause many industrial fires. The 3 elements of the fire triangle, heat, fuel, and oxygen, are present in most welding operations. The heat from the arc, torch, or hot metal, the fuel from gases or combustibles in the area, and oxygen in the surrounding air. Sparks can fly up to 35 feet or more and fall through any cracks or openings in partitions and floors. All combustibles or flammable materials should be removed from the welding area. The area itself must be constructed of non-combustible materials. No urethane foam or other insulating organic foam should be part of the area. Gas lines should be installed in accordance with codes and specifications. Fuel gas cylinders should be stored in specified, well-ventilated areas or outside away from oxygen. They should be stored vertically with valves closed and caps on, whether empty or full. Hot work or welding permits are required whenever welding or cutting is done on hazardous materials or anything that once contained such materials, or for areas not designated for welding. These are signed and dated by those involved. Hot work permits are especially needed for maintenance welding, such as with construction equipment in the field, aircraft, ships, or other potentially hazardous areas. Have a fire extinguisher within easy reach, and when the danger is great, have an extinguisher operator standing by. Containers must be given special attention. Vent any confined air before welding. Empty containers must be prepared properly to eliminate dangerous chemicals or other residues. Cleaning of containers is preferably done outdoors. If it must be done indoors, assure that the area is well ventilated. Drain all materials and match the cleaning method to the type of material. For water solubles, clean with water. Otherwise, use a hot chemical solution or steam. Cold water methods are less effective. The container can also be filled up to 25% with cleaning solution, then cleaned thoroughly. Afterwards, low-pressure steam is injected and permitted to vent for several hours. Then inspect the tank to make sure it is thoroughly clean, and then close any openings. Let it sit for 15 minutes, then test a further sample of the air inside. When the tank is determined to be safe, it should be so marked and dated. As an additional precaution, the container can be filled with water up to within a few inches of the weld area and vent the space above the water so air can escape. The container can also be filled with an inert gas, one that is not flammable or reactive. Compressed gas cylinders are always potential dangers. If the valve is suddenly broken, the pressurized gas can turn the cylinder into a rocket. The United States Department of Transportation and the Canadian Board of Transportation Communications set forth regulations governing gas cylinders. Some of the most important are: the contents should be legibly marked by chemical or trade name, using labels or decals. Cylinders should be condemned and never reused when they develop leaks, internal or external corrosion, dents, bulges, or any evidence of rough use that may have weakened the cylinder. They should be stored in cool, well-ventilated areas where the temperature never exceeds 130 degrees Fahrenheit. As mentioned earlier, they must be stored upright with the valves closed and protective caps in place. They should also be clearly marked when empty. Cylinders should be secured by chains or clamps, whether in storage or in use. Small portable cylinders should be mounted securely on specially designed trucks. Because the contents are under extremely high pressure, cylinders should not be dropped, struck, or rolled around. Use hand wheels to open the valve, not wrenches. Avoid strong magnetic fields, especially magnetic cranes, and make sure they are nowhere near the electric arc and its circuit. When slag is chipped or ground from a weld, it can fly with surprising force. Particles and dust are common in welding areas, so wear safety glasses with side shields. Welders may be required to work in radioactive areas. Qualified personnel should make the decision as to how welding should be performed in such areas. Excessive noise levels can cause hearing loss. Peening, chipping, air carbon arc gouging, or plasma cutting can create enough noise to cause temporary or permanent damage. If you're not sure about the noise level in your specific area, measuring devices are available and should be used. In some plants, hard hats should be worn to protect against falling articles. Keep the work area clean. Electrode stubs should be placed in containers and not just dropped on the floor where they can be a tripping hazard. If a question or problem arises where you work, consult the safety director. Remember, personal injury can be sharply reduced or practically eliminated by being aware, being informed, and just using common sense.